So let's look at hypothesis testing for variance and standard deviation. So again, to do hypothesis testing for variance and standard deviation, we really have to lean more on tables on this one. And we don't really have a shortcut for our test statistic. So we've been having a calculator kind of bypass the formula, but luckily this formula is not that complicated. So we're going to be okay here. But yeah, we will have to actually do these calculations here. And we will have to use a table to find these critical values here. So there's no, we're only going to use the calculator actually for calculations this time. So let's play this out here. So again, we do have to have uh, a sample that is, and the population has to be normally distributed. So that has to be given in our example. Again, we're back to, again, setting the null and alternative hypothesis. We are going to use the level of significance and the degrees of freedom to identify the critical values in the problem using our table. And then we're going to use this formula to find the test statistic chi-squared. And then with this information, we're going to create the rejection region and decide whether or not the test statistic falls within our rejection region. And then from there, we'll decide whether or not to reject H0 or fail to reject H0. And then again, we'll use this to interpret our hypothesis test. So based on where our claim is. So question 10 in your homework kind of looks like this. So we have a snack food manufacturer estimates that the variance of the number of grams of carbohydrates in the servings of its tortilla chips is 1.35. A dietitian is asked to test this claim and finds that a random sample of 19 servings has a variance of 1.43. And at a level of significance of 5%, is there enough evidence to reject the manufacturer's claim? So assume that this is normally distributed. So again, going through our problem, the first thing we want to do is write our claim mathematically and then identify what the claim is, or identify. So write the claim and identify the null and hypothesis, the null and alternative hypothesis. So anyway, we're going to write down H sub 0 and H sub A. And from there, we're going to pick up on that our claim is going to be that the variance, which again is sigma squared, for the number of grams of carbohydrate is 1.35. So that is going to be actually our null hypothesis. So the variance is going to be 1.35. So that means our null hypothesis is, I'm sorry, our alternative hypothesis is going to be the variance does not equal this 1.35. So from there, we want to identify our critical values. So from there, what we're picking up on is if I draw my chi-squared graph, remember zero's over here on the left. So if we draw this out, so we have chi-squared R, and we have chi-squared L. Now notice that since the alternative hypothesis does not equal 2, this tells me that we have a two-tailed test. So this tells us that we have two rejection regions. So we have a rejection region that is left of chi-squared L, and we have a rejection region that is to the right of chi-squared R. Now, to do this, we need to know what alpha is, and alpha was this 0.05. But since this is two-tailed, we have to divide the level of significance equally among the two tails. So 0.05 divided by 2. So we're going to do that briefly on the calculator. So 0.05 divided by 2, that's going to give us 0.025. So from there, we also need to know our degrees of freedom in our table. So remember, degrees of freedom is n minus 1. So since our sample size is 19, our degrees of freedom is actually going to be 18. Now remember, in our table, chi-squared r is going to be, let's see here, get this to work here. So remember, chi-squared r is this side of the table. And remember, that's simply alpha. And then remember, because of symmetry in the table, this is going to represent our chi-squared L values. So the 0.025 is going to be our chi-squared R value. So with 18 degrees of freedom, I believe we're going to be rounding to 2 decimal places. So that's going to be 31.53. So chi-squared R is going to be the 31.53. So that's going to be over here on this side, 31.53. So if we're to the right of 31.53, that would be the rejection region on that part of the tail. So the flip side of 0.025 would be this 0.975. That would be the complement. Remember, this is going to be 1 minus alpha. So if we do symmetry, that would be that 0.975. So 18 would be then this 8.231. So chi-squared L is going to be that 8.23 if we rounded 2 decimal places. I believe that's what your homework does. So that's going to be your 2 critical values. So our rejection regions are going to be if we are going to be, if chi-squared L is going to be less than 8.23, that's our rejection region. Or if we have this chi-squared R is going to be greater than 31.53. Let's pause for a second here, make sure I'm using the right notation on that. So actually, they don't clarify, they just simply say chi-squared. Those are, so remember, our test statistic is chi-squared. So if our test statistic is less than 8.23, we're going to reject it. If our test statistic is greater than 31.53, we're going to be rejecting it. So we now want to go ahead and find our test statistic, chi-squared. So remember, our formula was, for the test statistic, was the degrees of freedom, which is n minus 1, times the, it was actually the sample variance on the top. So the sample variance on the top divided by the population variance on the bottom. So degrees of freedom was this 18. The sample variance, let's see what that was in our problem. So when they did the random sample of 19 servings, there was a variance of 1.43. So 1.3 was the sample variance. And then we're going to divide it by the population variance, which was the 1.35 was our population variance. So this math isn't that hard to calculate. So see if we can find our calculator here and do this math here. So 18 times 1.43, get that answer, and then divide that by 1.35. So it's going to give us, if we round that to 2 decimal places, that'd be like 19.07. 19.07. So does 19.07 fall within our rejection regions? Looks like 19.07 would be somewhere out here. So it does not fall within the rejection regions. So we're not rejecting H of 0. So we're failing to reject H of 0. So from there, we have to go back and look where our claim was. Our claim was, excuse me, our claim was the null hypothesis. So if we're failing to reject that, then if you recall, based on our little table, if we fail to reject H0 and our claim is H0, then there's not enough information to reject the claim. So we can't say it's true, but we can't also, we're not going to say it's false either. So again, there is not enough evidence. So that's how it says to reject. So there is not enough evidence to reject the manufacturer's claim. So we're going to be using the words is not there. That enough evidence to reject the manufacturer's claim that the variance of the number of grams of carbohydrates in the servings is 1.35. So we're kind of staying put with that. So it kind of takes you through a hypothesis test for variance.